Hi everybody, so this is going to be the second part of the lecture for chapter 14. So now we're moving on to the concept of heat. So here, let's go back to the computer simulation about what atoms look like. So here, this is a gas. Let's look at this other one here. So here you have the different states of matter. You have a solid, you have a liquid, and then you have a gas. And this is for oxygen here. And let's look at water. So water as a gas is water vapor, and then if you notice the temperature, water vapor has a high temperature, 400 kelvins. You cool it down to become a liquid. It drops to 286 kelvins, and you cool it down some more, and you're going to freeze the liquid water to become a solid, and there the temperature drops to about 146 kelvins. Okay, so now we're going to concentrate on solids. So let's go to this solid here, just in general. Atoms arrange themselves in a nice crystalline, in a nice crystal shape, but they still vibrate. So the atoms can't go, they can't move freely like a gas. They can only vibrate, but they can't travel much. So that's the part they're going to look at, the vibration of the gas, of the atoms inside of a solid. So let's say that you have this pipe. And this pipe here has gas atoms inside of it. Let me pick a different color. So those atoms in the solid, they can't move anywhere, but they do vibrate. Okay. So if you place this pipe underneath above a flame, so this is going to be the hot area, and here this is going to be the cold region. If you were to place your hand on the cold region, after a while you're going to get burnt. And well, the reason you get burnt isn't because the atoms themselves move from the back end here to your hand there, because they can't go anywhere. So something else had to move in order to burn you. And what burned you, we're going to say, is this concept of heat. So it's going to be the fact that the flame emits some energy, and that energy heats up the atoms closer to the flame and makes them vibrate a lot. And then that vibration carries down to the atom next to it, that carries over to the atoms next to it, and eventually that vibration, once it reaches your hands, then you get burnt. So we're going to say that heat, then, it's actually a transfer of energy. It's energy that's traveling from one end of the pipe to the other. That goes from this end to that goes from the hot end to the cold end. So let's be specific. So we're going to say that heat, or the letter capital Q, what that is, it's a transfer of energy. But there's one more important part to that. From a hot region to a cold region. From hot to cold. So heat only travels from hot to cold. Spontaneously, it only goes from the hot region to the cold region. So let me just redraw this there. If you have a pipe, this is actually, let me do another example. A car. So let's say that you have a car. So you're going to have your hot engine here. That's going to generate a lot of heat. So this is going to be the hot side here. And then you have your muffler at the other end over here, and it's connected to the air outside, so to the environment. So that's going to be the cold region. And so the reason that you can move gears around in your car is that the heat flow moves the gears around, and the heat always travels from hot to cold. So it starts from the hot region and winds its way up to the cold region. So heat always goes from hot to cold, and heat is going to be a form of energy, so it's going to have units of joules. Okay. This simulation is going to help us to understand what heat is. So what we're looking at here is there's a flame, and then you imagine that this is a piece of iron, and these black dots represent the iron molecules, and they're arranged in a regular grid. So if we, and this system is going to start off at 20 degrees Celsius. And let's go ahead and turn on the flame. So what you're noticing is that near the flame, this iron molecule vibrates faster, and fast means temperature, so that this iron molecule is hotter. And over here at this corner, this iron molecule is vibrating slower, so it's at a lower temperature. So then let's just restart the simulation then. So for now though, the faster the vibration, the hotter this represents the hotter region. So now let's rerun this again. So now let's see what heat is. So what you're noticing is that progressively as time goes by, the region beneath the flame or above the flame is orange, and then orange spreads out throughout the rest of the piece of iron. So let's see why that is. So let's reset the simulation again. So it's spreading throughout that piece of iron is heat. And so the way that we're gonna define heat is we're gonna say that heat is a transfer of energy, which is the motion of these gas molecules. So it's a transfer of energy from a region that's at a high temperature, meaning right next to the flame, to a region of low temperature, which is at the opposite end of this piece of iron, like somewhere around here.